Hi student. Now I will talk about solving quiz number 2. It is about Newton's second law and projectile motion. For the projectile motion we will use the position and velocity vectors. By the way, you will see them given in the first test, so you don't need to carry them. We have a projectile object which is a ball. We need the maximum height for this ball. At the maximum height, the vertical velocity is equal to 0. We have the position vector and the velocity vector. From the velocity vector, the y component of the velocity is equal to 0. By use this fact, then we can find the time at this point. Then when we go to the y position to find the maximum height, finding the maximum height means we need to use the y component from the position vector. The y component, everything is known unless the time. We need to find the time. The time is from the velocity component, the vertical velocity. Okay, we will use the vertical component from the velocity, equal it with 0 here, v naught sine alpha naught minus gt is equal to 0. By finding t, which is 0.815, we can use this t in the position relation. Then we find this is the position relation, which is v naught t sine alpha naught minus half gt squared. When we put t, which is this one, g and v naught and alpha naught are unknown, then we can find that y, which is at maximum point, is equal to 3.25 meters, which is approximately 3.2 meters. Also, if we put this t in the x component of the position vector, we can find the x component from the position vector. If you need to find the range, it is twice this part. This total range is equal twice to the half distance. Now, this is the first question. The second question, we have a mass 4 kilograms. We have 4 forces on it. All of them, we have 3 of them on x-axis and y-axis directly, but one of them has an angle 30 degrees above the x component, the x direction, yes. Then we have 2 components for f1, which is f1 cosine 30 on x-axis, positive x-axis, and f1 sine 30 on positive y-axis. Now we are asking about the acceleration. We are not asking about the force. We don't need fx. We need the acceleration. You have to you need to find the force in x direction, then find the acceleration. Okay, now how much the total force in x direction? Simply, it is the forces on positive x direction, which is f1 cosine 30. On the negative x direction, we have f3 with negative sign because it is on the minus direction. f1 is given, cosine 30 can be found, and f3 is 5. Then the total F on x direction is 3.66 newtons. Positive means in positive x direction. Now we found fx. What is the acceleration? Be careful about that. We don't ask about just fx, we ask about the acceleration. The acceleration in x direction is fx over the mass. Fx given, the mass is given also. Then the acceleration is approximately 0.92 meter per square second, which is this answer. Now, question number 3. It is the same, but we are talking about the y components. So the total y component from these forces is F4 upward and F1 sine 30 upward and negative F2. F2 is in negative y direction. Then the force in y direction is equal to negative 33 newtons. Negative means to the negative y direction because we are talking about y. What about the acceleration? It is easy. It is the total force divided over the mass, which is negative 8.25, which is approximately minus 8.3. You may see approximated values in the choices. Okay. The fourth question, it's simple. Using the given table, if your mass is 90 kilograms, on which planet your weight is the smallest? As we know, the weight is equal to mg on that planet. So the mass is constant everywhere. So we need to find g at that planet. We need the smallest g. We have two values for small g, which is at Mars and at Mercury, but at Mercury is less than at Mars. So our weight on Mercury is the smallest. So the answer is Mercury. We don't need to calculate anything. Just also like the final question. If your mass is 90 kilograms, sometimes you see that if your weight is 90 kilograms, it is just a word, okay? But the meaning of it is the mass. I'm asking now in physics, how much your mass on Jupiter, okay? I don't need to calculate anything. The mass is constant. On Jupiter, on the sun, on Earth, anywhere my mass is constant. It is 90 kilograms. Okay? Be careful about that and good luck.